Okay guys, we will continue with the topic redox in basic solutions. So we have dinitrogen oxide, hypochlorite ion, nitrate ion, and chloride ion. The first step is, as usual, we need to get the oxidation number of every element that is in the reaction. Now, remember that ions are going to express the same oxidation number as their charge. Example, chloride ion, the charge will be -1. Now here we have an ion, okay, nitrite ion. So you know the oxidation number of oxygen, the rule of oxygen is -2. Therefore, in order to balance nitrogen with oxygen, should be 4. But as this is an ion, it's going to be equalized to -1, not to 0. Therefore, the charge should be 3. Because 3 minus 4 gives you -1, which is the charge. Or you can do it apart, like NO2 minus 1 nitrogen plus 2 oxygens equals -1. 1 times nitrogen is just nitrogen, plus 2 times -2 equals -1. Nitrogen minus 4 equals -1. Nitrogen equals -1 plus 4. Nitrogen equals 3. It takes a little longer, but if you want to make sure that you did it right, you can also do it in this method. The oxygen rule is -2. Okay, in order to balance with it, chlorine should have 1, because 1 minus 2 gives you -1. But you can do it apart too if you want. ClO minus 1 chlorine plus 1 oxygen equals -1. So chlorine plus oxygen equals -1. Chlorine minus 2 equals -1. Chlorine equals -1 plus 2. Chlorine equals 1. So it doesn't matter the method you use to get it. Okay? The answer should be the same. And in here, we have a -2 for oxygen. And therefore, this one should be 2 times 1. Okay? 2 times 1 gives you 2, and 2 minus 2 gives you 0. So we are cool. Or you can get it here too, okay? You can do it there. Let's see. N2O equals, this is a compound, so it should be equalized to 0. So 2 nitrogens plus 1 oxygen equals 0. I want to know what nitrogen is. So 2N plus 1 times the charge, 0. 2N minus 2 equals 0. 2N equals 0 plus 2. 2N equals 2. N equals 2 divided by 2, because this one is multiplying. So 2 divided by 2 is 1. Okay, the oxidation number is 1 times 2, 2 minus 2, 0. Okay, so let's continue. Now, we need to determine what element is being oxidized and what element is being reduced. So let's see. For reduction, we have from chlorine 1 to chloride ion. And for oxidation, we have nitrogen 1 to nitrogen 3. The oxidation number increased. So let's continue. REDOX method. Now, we're going to continue writing the equations, the half reactions. Reduction occurs from hypochlorite ion to produce chloride ion. Oxidation occurs from dinitrogen oxide to produce nitrite ion. Now, after we write the half reactions, we need to balance them. So remember to write the charge is important because this one comes from 1 to -1. So the difference of electrons is 2. So here I will be adding 2 electrons in my reactants. Okay, plus 2 electrons. Now, here I have oxygen, here I do not have oxygen. So I need to add, as I need 1 oxygen, I need to add 1 molecule of water. Remember, the procedure is the same that we used to do in acidic solution, and a couple more steps. So here plus 1 water molecule. And now here I included hydrogen, so I need to balance hydrogen by adding hydrogen ions in my reactants. So as I have 2 hydrogens here, I will be adding 2 H plus ions in my reactants. And we're okay. Now, in my oxidation, I have 2 nitrogens here and only 1 over here. The first step that I need to do is I need to balance the number of atoms of nitrogen atoms, 2 and 1, so I need to multiply this part times 2. Now, remember, we need to include the charges. This charge is 1, this one is 3. So take a look here. 2 times 1, I have 2 electrons. And here I have 2 times 3, I have 6 electrons. So in order to balance this, 6 minus 2, I need to add 4 electrons. I have 4 oxygens here and just 1 over here, so we need to balance adding water. 4 oxygens, only 1, so I need 3 water molecules, 3H2O, okay. And now in this side, because here I have hydrogen and here I do not have a hydrogen, I need to balance that. 3 times 2 makes 6 H plus ions. Now, everything looks okay until now. What do we have to do? Look at this. We have 4 electrons here and 2 electrons here and 4 electrons there. So that means that I need to balance the number of electrons. In order to do that, in order to get 4 electrons, I need to multiply this equation times 2. Okay? Or you can do a cross multiplication and at the end of the steps you can simplify. It's okay. No matter the method you use, but you need to balance. I will do it like you do it, okay? I will cross multiply this one times 2 and this one times 4. So I will have to add all these. So I have 2 times 4 gives me 8 H plus ions plus 4 hypochlorite ions plus 8 electrons produce 4 chloride ions plus 4 waters N2O plus 6 waters produce 4NO2 minus plus 8 electrons plus 12H plus ions. Right now what it comes is just to cancel the amount of electrons in both sides of the reaction. So here and here, and add all, okay? Now what it comes is you need to see the common factors for that chain, or the common molecules in both sides of the equation. So we have H plus ions here and 12 plus ions here, so you need to add them, or in this case subtract them because they are in opposite sides. So 8 and 12 makes 4, the difference. 12 minus 8 is 4, and I will write 4 where I have more hydrogen ions. So this one will be erased. So my result here is 4H plus ions. Now I need to see what other molecules I have in common. As you can see, I have water and water. Now here I have more waters, okay? So 6 minus 4 is going to give me 2 water molecules. So it will be 2H2O. And now, let's see. Let's copy the rest, okay? Now what it comes is that what makes this a basic solution, that is, we need to add hydroxide ions. How many ions? As much as the hydrogen ions. So you have 4 hydrogen ions. That means that you need to add 4 hydroxide ions here, but also in my reactants. So 4 OH ions, okay, in both sides of my reaction. So after this, you need to see in the place where you have H plus OH, you're going to add them in order to get water. As you can see here, we have this situation. Beautiful marker, by the way. This will make 4H2O. This is the condition that I wrote yesterday, okay? So 4H plus 4OH minus gives me 4 waters. And here I don't have H plus, so I don't have to add it with anything. It's going to remain there. So now it's just my time to rewrite the equation, okay? Okay guys, we finished for that chain, but as you can see, 4, 4, 2, 2, 4, 4, 4, these coefficients are divisible by a number, okay? By what number is that? They are divisible by 2. So in this moment, what I'm going to do is I will divide all my equation by 2 because I need to simplify. So I will divide this by 2, okay? And I will have 4 divided by 2, 2 OH ions, plus 4 divided by 2, 2 ClO minus, plus 2 divided by 2 is 1 and 2O, plus 2 divided by 2 is 1 water, produce 4 divided by 2, 2 chloride ions, plus 4 divided by 2, 2 NO2 nitrate ions, plus 4 divided by 2, 2 ions, 2 waters. Now, as you can see, I kind of forgot. I always do. But the good thing is that I realized here I have this and that. Okay? That means that I need to subtract. 2 minus 1 gives me 1 water that I'm going to write where I have more waters. So this will be 2OH minus plus 2ClO minus plus N2O produce 2Cl minus plus 2NO2 minus plus H2O. Now what comes next is to check if we have everything balanced. Okay, so let's compare chloride. 2 and 2 chlorines, we are okay. 2 nitrogens, we are okay. Hydrogen, I have 2 hydrogens here, and here have 2 times 1, 2, so we are okay. And about oxygen, I have 2 times 1, I have 2, plus 2, plus 1, I have 5 oxygens here, and in my products, I have 2 times 2, 4, plus 1, 5. 5 and 5 oxygens means that everything is balanced, and that we already finished to balance our reaction by the method ion electron in basic solution. So right now what I'm going to do is I'm just going to box my answer to indicate that this is my final answer, that I don't need to subtract waters or anything similar. Okay, so guys, thank you for watching. We are cool. Bye.